Welcome to this video demonstration. This video shows how the solver electromagnetics for Simcenter can be used to simulate engineering problems with electromagnetic mechanical coupling. The electromagnetic solver is an add-on product to Siemens Simcenter 3D. It is developed, supported and delivered by Dr. Binde engineers, a solution partner of Siemens. I want to show two examples, both containing the same physical effect. One example is more academic, the other more realistic in practice. Both examples deal with electric wires being affected by magnetic fields, so Lorentz forces will appear and act on the wire. We are interested in the mechanical behavior of the wire, deformation, stresses and reaction forces of the conductor due to Lorentz forces. So the solver will do an electromagnetic solution first to find the Lorentz forces, then do a mechanical elasticity solution to find deformations, stresses and reaction forces. All this is done either completely integrated in the magnetics solver or by a coupling of NX magnetics with NX nastran. See the first, more academic example. A wire is placed between two permanent magnets. We do a static simulation just to see the effect of Lorentz forces acting on the wire. The model is ready to solve. It comes from the training material of NX Magnetics. Let's solve. This only takes some seconds. And it has finished. Alternatively to using the magnetics internal elasticity solver, we can also use NX nastran for the elasticity part of the solution. In post-processing, we first check the magnetic field . This magnetic field is mainly coming from the two permanent magnets. Of course, the wire creates a rotating magnetic field additionally. Let's now see the Lorentz forces being produced. And finally, let's see the deformation and stresses in the wire. Now let's go to the more realistic example. It is a circuit breaker for low voltage conditions. Again, there is a wire, now more massive and modeled as a coil. In this case, there are no permanent magnets, but there is a magnetic field produced by the electric current itself. This field now also creates Lorentz forces on the wire. We analyze the short circuit case. So the electric current increases very fast in a short time period. The current definition is therefore now given by an analytical law containing sinus and exponential forms. We have applied 2 times the usual value in this simulation just to see more effect. So the solution now is a transient one with 30 time steps. Solve time will be about 1 hour on a desktop computer. Here we see the definition of the elasticity solver being coupled to the electromagnetic solution. It is set to transient and we want to use the electromagnetic forces in the elasticity solution. Let's see the requested results. We see the current in the wire as a plot result. Of course, we are also interested in the behavior of the current over time. So we see our tabular results all available here in the navigator. The current result is this one. And we see that the current increases in a short time period and it goes up to 510 amps. Next, let's see eddy currents. They are of interest for further computations of losses. Here are all the eddy current results. Let's plot them. And we see that the most important one is the one on the coil, and this one produces a maximum of about 1000 watt. Let's see the magnetic flux density as a plot result. This result is good for validation purposes. See how the wire produces a rotating field. This field can also be used to check for EMC, electromagnetic compatibility, for the shielding effect of the housing. Next we see the force acting on the plunger. We also want to see the force behavior over time. So let's plot these three curves. And we find that the maximum force is the Z direction and it has a value of about 8 newtons. Finally, let's see the deformation and stress results in the coil as an animation. Also, we want to see the maximum values of deformation over time. So we see the maximum deformation is the one in the Z direction again, and it has a value of about 1.3 millimeters. Many other results are available, like magnetic forces and reaction forces or torques. In further simulations, we can also ask for temperatures or the plunger motion. Many thanks for watching this video demonstration. If you have questions, please contact the Simcenter experts at Dr. Binde Engineers.